3D printing with robots can be easily accomplished in a few steps using RoboDK. A 3D object, such as STL, can be first sliced into different layer paths, then you can simulate the 3D printing program. You can generate the appropriate program for your robot once you're satisfied with the result. In this case, we're using a Nachi robot, so RoboDK will generate a program that Nachi robots can understand. We can modify 3D printing parameters, such as the layer height, to obtain better accuracy results. A new path is then calculated. Since we reduced the layer height, the path will be more detailed. However, the time to 3D print will be longer. We can also modify other parameters such as the tool orientation of the robot. Whenever we want to see the result, we can select Update and double-click the program. Finally, we can select Edit Path manually, and the slicer window will show up. We can then load a part to have an idea of what the 3D printed object will look like. By changing slicer parameters, the final result will change. We can also see the path layer by layer. We will now create the same simulation from scratch. We can start by opening the online library and loading the robot and tool that we need. For this example, we'll use an extruder tool and a Nachi robot. It's also possible to include your own tools and robots by modeling them yourself. We must drag and drop the tool to the robot so that it can be used by the robot. We must also add a reference frame to tell the robot where we want to 3D print. Any object can be renamed with the F2 key. We can move reference frames and other objects by using the Alt key. Finally, we'll add an STL object. RoboDK also supports other formats, such as STEP and IGES files. We must drag the object and drop it into the 3D printing reference frame. We must select the Utilities menu, then 3D Print Project, to tell RoboDK that we want to start a 3D printing project. This menu allows us to modify the slicing parameters as well as the preferred tool orientation. The robot, reference frame, and tool must be properly selected. Then we can select the object and the tool path is automatically calculated. We can display the preferred tool orientation. In this case, we see that the orientation of the tool is incorrect. This happens because RoboDK matches the Z-axis of the tool with the extruder axis by default. The Z-axis is the blue axis. We can double-click the tool and change the tool orientation manually. We can see that a rotation around the Y-axis of 90 degrees will place the Z-axis at the right spot. The Y-axis is the green axis, and the X-axis is the red axis. We could have also used the Alt and Shift keys to move the tool axes with the mouse. Anytime, we can select Update and double-click on the program to start the simulation. RoboDK will tell us if the path can't be reached by the robot, if the object is too far, for example. There are more parameters that can be used to customize the robot path and allow the tool to rotate around the z-axis. For example, we could have added the tool orientation in this menu to adjust the z-axis orientation. RoboDK supports milling with external axes, such as a turntable. In this case, more optimization options become available.